Okay, so these are our first notes that start with our atmosphere unit, our weather and atmosphere unit. And this picture kind of gives you a really clear idea about what's going on with our atmosphere. If you look down here, what you're actually looking at is the sunrise you're looking at the sunrise from outer space. So this part right here is the Earth, and you can see the sun right there. It's really tiny. And then these thin blue lines right there, that is our atmosphere. When we talk about our atmosphere, it seems like it's really huge, but when you look at it from outer space, you can see how thin it really is and why it's so important for us to take care of it. We're getting into our first objective, which is objective 7. I can define the atmosphere and identify the composition of the atmosphere. That means I can tell you what it's made up of. So the atmosphere itself is a thin layer of gases that are surrounding the Earth. You guys just saw how thin that layer is compared to the Earth in the previous picture. It's made up of 78% nitrogen, 21% oxygen, less than 1% water vapor, carbon dioxide, and other trace gases, which means there's not a lot of that, but there is other things in our air. Most of it's nitrogen, and then 21% of the air we breathe is oxygen. There's also a bunch of particles floating around everywhere in our atmosphere, and those are important. We're going to talk about those when we get into the water cycle and how those little particles are important for precipitation. And the atmosphere is essential to our survival of life on Earth. Without it, temperatures would drastically change between night and day. The atmosphere helps keep the warmth in on our Earth. It helps to protect us from radiation from the sun. It is super important. Okay, again, this is another slide just showing you the makeup of our air. 78% oxygen, 78% nitrogen, 21% oxygen, 1% water vapor, carbon dioxide, and other trace gases. Okay, to remember the composition of our atmosphere, we use this little acronym, Never Open Canned Worms, and it is in order from least to most. So if we look at never, that stands for nitrogen, which is 78%. So the first one we say is the most. Open goes for oxygen, again, that's 21%. Canned is carbon dioxide, less than 1%. Worms, water vapor, again, less than 1%. And then there's some other trace gases in our atmosphere. So never open canned worms. It is in order from the most abundant to the least abundant. And just another slide showing you how the gases in our air are made up. Okay, you have all different kinds of things. N2 is nitrogen. You can see how there's a lot of nitrogens in comparison to everything else because it is 78%. Okay, O2 is oxygen. Here's some oxygen. Okay, then we have H2O, which is water vapor, CO2, carbon dioxide, and then we have other things like CH4, SO2, sulfur dioxide. Okay, other trace gases are in our air, but the ones that we need to be most concerned with, the ones that you are responsible to know, is nitrogen, 78%, oxygen, 21%, carbon dioxide and water vapor, both less than 1%. Okay, those are the 4 that you need to know. All right, objective 8. I can describe the layers of the atmosphere and label the layers and the pauses. You are going to label, the diagram on the next page in your notes. Okay, so let's go look at that. All right, so here is a pretty good drawing of what's going on in the layers of our atmosphere. The layers themselves right here, this is the troposphere, stratosphere, this one is the mesosphere, thermosphere, and extending out into outer space is the exosphere. Okay? Between each of those layers, there are what is called a pause, and it is just a line that separates one layer from the next. So this layer right here, where's my pen? There we go. This line right here is the tropopause, followed by the stratopause is this next one, the mesopause, and the thermopause. Again, the pauses are just what separates the different layers, okay? I'm going to clear that and go back to it so that you can label those in your notes. Okay, don't worry about drawing any of the other stuff right now. Just label the different layers and the pauses in your notes. Okay, to remember the layers of the atmosphere, I have another acronym for you. It's the Sandman took Elmo. Okay, starting at the Earth, and I'll go back up here to this other picture. If we start from the Earth, right here, and we say the Sandman took Elmo, the stands for troposphere, sand for stratosphere, man for mesosphere, took for thermosphere, and then Elmo for exosphere. So if you remember the Sandman took Elmo, we're starting from the Earth going outwards. It will help you to remember the layers of the atmosphere. Okay? Continuing objective 8, we're going to start talking about the first layer of the atmosphere. It is the lowest layer of the atmosphere. It's the one that we live in. All weather occurs in this layer. All your clouds, precipitation, some storms. Some of your clouds extend up into the stratosphere, but for the most part, they are mostly all in the troposphere. Again, we live in the troposphere. It's the layer that is closest to the Earth, and it is constantly changing. Guys, you can look outside at any one time, and one time you're going to look out in the troposphere, it's going to be clear and sunny, and another day you look out there and it might be cloudy. It is always changing. It changes with the weather because weather is occurring in the troposphere. Our next layer is the stratosphere. It is super important to us. The ozone layer is located in the stratosphere, and the ozone absorbs ultraviolet light that is harmful to us from the sun. It's a protective layer. You guys know that when you go outside, you put sunscreen on, and if you look at your sunscreen, it will say UV protection. Okay, that's the ultraviolet light, and we need protection from that. So our ozone is really important to us because without that, we would have a huge increase in people getting different kinds of like skin cancers and things like that. So it's really important to us that we keep our ozone layer protected. As we go up into the stratosphere, our temperature increases with height. Because of the absorbed radiation, our temperatures are going up. Up here in the stratosphere, you are above weather. Only the largest thunderstorm clouds reach up to the stratosphere. That's what I was talking to you about earlier. So when you're flying in an airplane, and I think you saw on one of the slides earlier, you saw like jets and stuff up there in the stratosphere right there by the tropopause. They fly up there so that they can fly above the weather. So even if there's a huge thunderstorm going on, that airplane will still be able to fly if it can fly above it. All right, the next layer of the atmosphere is the mesosphere. The word meso, M-E-S-O, means middle, and it is the middle layer of the atmosphere, our third layer. The outer parts of the mesosphere are the coldest parts of the entire atmosphere. And you can remember that the meteors burn up in this level. Okay, mesosphere, meteors burn up. Okay, the M and the M. In the mesosphere, meteors burn up. Again, it is a protective layer because your meteors are burning up in this layer, so they're not ever going to reach the Earth. Okay? Extending out into the thermosphere, as we go up, the density of our air goes down. So as we extend out into outer space, our air molecules get further and further apart. So as we're up into the thermosphere, our air is really thin. Okay, think about trying to climb up a huge mountain. As you're climbing up, it gets harder and harder to breathe because your air molecules are spread further and further apart. Okay, the thermosphere is our hottest layer because it is closest to the sun. The closer we get to the sun, the hotter it is. However, because of our air molecules being so spread so far apart, we wouldn't feel how warm it is because there is nothing there to hold the heat for us to feel that it's hot. And we'll talk about this more in class. The ionosphere is in this layer. Your radio waves bounce off of this layer, and also your aurora borealis, also known as the northern lights. They glow from the ions in the sunlight, so your aurora borealis or your northern lights are located out in the thermosphere. And then extending out from the thermosphere into outer space is called the exosphere. That word, E-X-O, That word part means outer, so it is the last layer. It's the outermost part of the thermosphere. Some of your satellites orbit in the exosphere. Telephone and television signals are sent to satellites that are located in the exosphere. But with the exosphere, we don't know where it ends. There's no clear line to say, okay, the Earth's atmosphere is done. We don't know where it ends. We just, it extends out, and because the particles are so far apart, we don't know exactly where the atmosphere ends and space begins. And I guess that is it for this week. You had Objectives 7 and 8. Make sure that your video notes are all filled out. If you have any questions, please bring them into class and ask as we are going over our notes. All right, I'll see you guys in class.